Hello, this is Todd Frazee, and this is the tutorial for assembling the TCOSE piston assembly. Now this sub-assembly doesn't have a call out on the drawing, and but we have two instances of these cylinders that have motion. So if we make a sub-assembly, we only have to assemble one half, and then we can uh, bring in each sub-assembly into the major assembly, which should make things a little easier for the final assembly. So what we're going to do is we're going to assemble the dash 8 with all the components that mount to it, which include the dash 9, the dash 10, and the dash 12, dash 11 components plus hardware. So this is the first one where you're going to bring a sub-assembly, which is the dash 11, into another assembly file. Okay, so let's start with the dash 8 since it's the major component that everything amounts to. And first we have to save the file. So we're going to call this the TCOSE cylinder assembly, and we're going to abbreviate assembly. Save. And now we can open our data panel. Okay, we're going to bring in our dash 8 model. We're just going to accept its natural location, hit OK, and we will ground that model. Alright, so the first thing we're going to install in this is we're going to go ahead and put in the dash 11 subassembly. So you're going to scroll down until you see the TCOSE 11, not the 11A and B and C, but the 11. And we're going to pull the piston assembly in. That's actually pretty close to where we want it, but I'm going to drag it off to the right a little bit so that we can look at it. Is it okay? So the cylinder slides back and forth. The piston slides back and forth in the cylinder. In its design state, it could spin also, but once it's mounted to the drive assembly, the hole in this end of the rod is going to be parallel to this face of the piston housing. And so we want to assemble it as such. So we want to use a joint assembly, and we're going to pick the end of our cylinder at the center. Then our corresponding edge is going to be the center of the opposite end. Before we do that, let's change our type to cylindrical and pick the extreme end of the travel. Okay, it's going to give us a little simulation, and we'll hit OK. Now let's right click on the joint that's been made on the tree, the history tree, and we're going to hit edit motion. So our rotation, we're going to set a minimum of 90 degrees and select OK. And what that'll do is it'll force the rotation to be 90 degrees from what it was when it first came in, and it'll force it not to rotate. It'll still have a cylindrical motion, and it can move back and forth. Now we're going to go back to edit joints. We should have done this instead of exiting, but we're going to hit slide. Now we're going to change the slide. The minimum is going to be 0, and the maximum is going to be the length of our cylinder block. And so the length of our cylinder block is 44 millimeters. So our maximum travel will be 44 minus the height of the cylinder, which is 6. So it's actually going to be 38. Our piston can only travel back and forth the length of the cylinder. Okay, that should be really the only moving part. And what we're going to do next is we're going to put the two heads on that would capture the cylinder. So that is the -9 and the -10. So let's bring in the -9. And let's flip the -9 as if it would mount where it's supposed to go. Hit OK. I'm going to go ahead and bring in the -10 while we're here. And we're going to rotate it as if, no, it doesn't need to move at all. And we're going to move it out of the way. Now if you look at this assembly, technically this component probably should have been part of the -11 assembly. It actually has to be mounted on the rod before the piston is connected to the rod. So assembly wise, we're doing it virtually. It works, but in reality it would have to be done differently. Okay, so let's put the -9 on first. We're going to select joint, capture position, and we're going to pick on the actual edge of the flange. That way we get the center, but it's at the level at which it'll mount to the cylinder. The boss you see goes inside the cylinder, and now that I look at it, we need to adjust the travel of the piston so that it's 1 millimeter less on both sides. So select, and then we select the center of the cylinder, and we're going to change our type to rigid. And then you notice the bolt holes don't line up. Okay, we're going to put an angle of 45 in, and now our threaded holes are aligned with the clearance holes for the bolts. Select OK. Now we're going to go over to the -10 part. Again, we're going to select joint. You're going to select the inside diameter in the same plane as the flange. And we're going to go back over to our cylinder, and we want the edge and the center. Okay, and now we need to go back to our angle, and we need to put 45 degrees in to clock the bolt holes. Select OK, and we should have our cylinder heads all aligned. Okay, so at this point we have the assembly functional, and we just need to add hardware. So we should be able to slide this back and forth. Now let's modify the travel on the piston to account for the bosses on either side. They're 1 millimeter tall, so we need to go back to that joint and edit it. Okay, so it should be right after the component. We highlight the component and it'll show up with these little tick marks, and it should be the joint that followed it. So we're going to edit joint limits, and we're going to leave the rotation alone. We're going to go to slide, and we're going to put in a minimum of 1 millimeter. And a minimum, and the maximum of 37. So you're not going to see anything visible, but you'll be able to travel 1 millimeter less and be on each side and be realistic. Okay. All right. So now we just need the pins. So there's, if we look at the -8 drawing, pin that goes on either side. One has a threaded threaded feature on it, and one is just a press fit. And then we also need to put in the M2 by 8 screws that hold the heads on. So let's start with the 3mm plain pin, and it is 11 millimeters long. So we're going to go to insert, and we're going to insert a Metcaster car part. Now again, we want pins. And we want a dowel pin type. Want dowel, metric. The diameter is 3 millimeters. Length 11. We may not be able to get 11. Looks like we got an option for 10 or 12. What we're going to have to do is select 12 and maybe shave a millimeter off. We're going to go chamfered, standard tolerance, stainless steel, 316, plain end, and then we're going to go to product details, scroll down until you see the 3D models. You want 3D SAT, and we're going to save it. And here we have our pin. Let's move it out of the way so we can see it and select OK. Okay, click into space as deselected. Right click on the pin. We're going to edit feature, and we're going to create a sketch on one end of the pin. Alright, once you're in that view, we're going to draw a circle on the center of the pin. Somewhat arbitrary, it doesn't really matter what diameter is, as long as it's bigger than the pin. And we'll put a dimension on it. And you're going to hit finish sketch. And we're going to do a extruded cut, which this is confusing because we can see the entire model. So let's make the rest of the model invisible for now, so that it makes a little more sense by selecting on the eyeball icons. And we're going to go a distance. We're going to cut inside the circles, and we're going to go negative 1 millimeter. And it's going to turn it into a cut. And select OK. And we now have the one side of the pin trimmed down to the length that we're supposed to have. Hit finish base feature. And now we can turn the rest of our assembly visible again. So in this joint, it's going to be a little tricky. We have a pin that's going in a hole, but we don't want it to go to the bottom of the hole because it will go through into the cylinder and stop the piston from going back and forth. So we're going to capture its position after we hit joint, and we're going to pick the center of the end of the pin, and then we want to pick the end of the cylinder, or end of the hole that that pin's going in. Now it defaulted to joining it backwards than what I intend, so we're going to flip the direction. And right now the pin is located at the very end of the hole. We know our cylinder diameter is 12. We know the distance from the edge here, this foot, to the center is 14. And we know the distance between this ledge and this base is 3. So if we take half the diameter and subtract it by, which is 6, divide it by the subtract it from the 14, we're left with 8, minus the 3 of this ledge. We should move this 5 millimeters in the z-axis. And we should have our pin below flush right at the bottom, just like we want. Select OK. Now we need the stud that goes in the opposite side. It's a pin with a thread on one end. It's a 3 millimeters with a pin with a M3 thread on the end of it that's 13 millimeters long. I suspect in the US we're not going to be able to get a 13 millimeter length, but we'll see. So we may need to shoot over and cut that pin down like we just did. Alright, so let's go out to McMaster Car. We're going to go to Insert, McMaster Car Component, and we're going to type in stud. Threaded studs. We want metric, and we want an M3. Okay, yeah, it looks like there's only one thread pitch available, and we want threaded on one end. Material steel, it's the only thing available, and it has a slot in it. We don't really care about, that's the way they come. Here's our length options. We can get 6, 10, and 12. So a 13 is not even available. So what we will have to do is get a 12 millimeter pin and press it 1 millimeter less into the hole. So we're going to select the 12 millimeter length. We're going to go to product detail. See there we have a custom pin made over 1 millimeter. Scroll all the way down. We're going to save the SAT file. Let's move it out of the way. And we're going to flip its orientation 90 degrees. I'm sorry, 180 degrees. And we're going to select OK. Now, this particular pin is 12 millimeters. And the pocket that comes down into here, this counterbore, is a millimeter deep. So if we have a 10 radius and we subtract 6 from that, we're left with 4. Minus the millimeter for the counterbore, that is 3. So we should have 3 millimeters of shaft here, or of pinhole here. So what we're going to do is we're going to join the end of our slotted pin. We want to pick the one of the circles so the snap point's in the center. And we're going to make a rigid joint with the center of the hole. And we're going to select the Z-axis. We're going to go -2 millimeters instead of 3. And that should give us enough protuberance that we have 13 millimeters sticking out from the dimension as called on the drawing. The downside is we don't have as much purchase and strength on that press fit. I'll say OK. Now all we have left is the screws that go in the ends. I'm going to demonstrate how to do it on one end of the part, and you're on your own for the other side. So let's go to McMaster Car. Okay, and we're looking for screws. And we're not going to be specific in our type in. We want a metric screw. That's interesting. It gives inch sizes with the metric. And we're looking for, according to the drawing, an M2. It has brass in the drawing, but I don't think we can be picky at this point. And we're going to go for a length of 8 millimeters, which is what the drawing says. And we're going to go with a head type. We have different options. So we're going to go with a rounded head. And in the drawing he has a slot. And it's telling me that we have two different head types for that particular round, what they're calling a round head. It's a pan and a cheese head. Looks like a big wheel of cheese. All right, let's see. Let's scroll down and see what we have as far as materials available now. Plastic, stainless steel, and steel. So I'm thinking we're going to go with stainless steel, and that might decide the head type. We're going to go 316 stainless. And that determined the head type we have to have. We have to have a rounded head with a slot in it. We have to buy a box of 100. We go to product detail, and we're going to scroll down to the bottom, and we're going to save off our SAT file. Pull that. Pull the fastener over to the side, and we're going to rotate it in the orientation to go into the head plate. So it'd be 90 degrees this way, and we're going to hit OK. Now I need a total of 8 of those, but for this side I need 4. So I'm going to right click on the component. I'm going to say copy, and I'm going to pick an empty space and put paste, capture position. Oh, you have to hit OK. Then you hit repeat paste, select OK, and right click and hit repeat paste, and OK. So we have 4 fasteners right there. Let's go ahead and drag them apart from each other. Okay, so we have our 4 fasteners. Now we're going to create rigid joints with their corresponding locations. So let's go joint, capture position. I'm going to pick up the center of the first hole, rotate it around. I'm going to pick up the center of the bottom of the head of our first fastener. And it's going to do a weird animation. Hit OK, and it should show up where we want it. Voila. Let's repeat that procedure. Joint, center top of the cylinder of the smooth hole, center of the diameter of the inside of the head, rigid joint, select OK. Okay. I do the same thing. Joint, center top of the hole, rotate around, center bottom of the fastener head, select OK. Don't be disturbed by the animation, it's kind of loony. And then we'll do our last one. Top of the hole, bottom center of the fastener head, and OK. Alright, so I've now imported, copied, and put all the M2 screws in. Now it's your turn to do the same thing on this opposite side to complete the assembly. That's it for this tutorial, but you'll need to have 4 more screws in than what's shown. And then of course put a message on Canvas that you've completed the assignment.